following function represents the relationship between time t in seconds and height h in feet for objects thrown upward on Pluto. For an initial velocity of 20 feet per second and an initial height above the ground of 25 feet, we get h is equal to negative t squared plus 20t plus 25. A. Find the coordinates of the point where the graph intersects the h-axis, and then interpret this point. First of all, notice that in our equation that h is the dependent variable and t is the independent variable. So if we sketch a graph of this function, the h-axis will be the vertical axis and the t-axis will be the horizontal axis. Any point along the h-axis has a t value of 0. So to answer part A, we can substitute 0 for t in our function. We get minus the square of 0 plus 20 times 0 plus 25. When we evaluate this expression, we get 25. So the coordinates of the point where the graph intersects the h-axis are 0, 25. This means that the initial height above the ground is 25 feet. For part B, we're asked to find the coordinates of the vertex of the parabola. Notice that h is a quadratic function and the leading coefficient is negative 1. Therefore, the graph of the parabola opens downward and the vertex will be at the highest point. Let's first of all use our calculator to explore and find the highest point. We go to y equals to enter our function, and the independent variable on our calculator is x, so instead of entering minus t squared plus 20t plus 25, we enter minus x squared plus 20x plus 25. Next, let's create a table of values. We'll go to second window, which is table set. We'll use 0 for table start, and we'll increment by 1 second at a time. Then go to table, which is second graph. We see that the initial height of the object is 25 feet and that the object rises. We want to scroll through the table until we see the object reaches its maximum height and then begins to fall. Notice that the y values reach their maximum value of 125 when x is equal to 10. Also notice the special symmetry. On either side of x equals 10, the function produces the same value. 1 unit away from 10, the function produces a value of 124. 2 units away from x equals 10, the function produces a value of 121. So because of this symmetry, we know that x equals 10 is the axis of symmetry, and the vertex is 10, 125. To verify this symbolically, we can use the Vertex Formula. The Vertex Formula states that the vertex of the graph of a quadratic function is the point minus b over 2a, f of minus b over 2a, where b is the coefficient of x and a is the leading coefficient. For the given function, we see that b is 20 and a is negative 1. Therefore, we get minus b over 2a is equal to minus 20 over 2 times negative 1. 2 times negative 1 is negative 2, and negative 2 goes into negative 20 10 times. So the t-coordinate of the vertex is 10. To find the h-coordinate, we need to evaluate the function when t is equal to 10. The opposite of the square of 10 is negative 100. 20 times 10 is 200. Therefore, we get negative 100 plus 200 plus 25, which is equal to 125. Therefore, the vertex is the point 10, 125. For part C, we're asked to sketch the graph and label the axes. Well, we've already drawn our axes. We've got our t-axis is the horizontal axis and the h-axis is our vertical axis. We've determined that the initial height is 25 and the maximum height is 125. So let's use a scale of 25 along the h-axis. The maximum height occurs when t is equal to 10, so let's use a scale of 5 along the t-axis. We've already determined that the point 0, 25 is on the graph, so we plot the point 0, 25. We also know that the maximum is 10, 125, so we go ahead and plot that point as well. And by symmetry, we can determine that the point 20, 25 is also on the graph. We now connect these points using the shape of a parabola and the reasoning that t can't be negative and h can't be negative. For part D, we're asked to interpret the vertex in terms of time and height. The vertex is 10, 125. What that means is that after 10 seconds, the object reaches its maximum height of 125 feet. For part E, we want to answer the question, for what values of t does the mathematical model make sense? Well, looking along our t-axis, we see that the values of t that make sense are from 0 to a little bit more than 20. Remember that our scale is 5. 5, 10, 15, 20, a little bit more than 20. To find that value more precisely, we can use our graphing calculator. We'll go to y equals, and for y2, we'll enter 0. We want to determine when the height is equal to 0. Next, we'll create a good viewing window. We go to Window, and along our t-axis, we see that the values range from -5 to 30 with a scale of 5. So we'll enter -5 for x minimum, 30 for x maximum, and an x scale of 5. Along the h-axis, notice that our scale is 25. So the values range from -25 to 200 with a scale of 25. So we enter -25 for y minimum, 200 for y maximum, and a scale of 25. And then we go to the graph. The parabola is the graph of y1, and the graph of y2 is the x-axis. We want to find this point of intersection where the t value is a little bit more than 20. So we go to Calculate, Second Trace, and we select number 5, Intersect. First of all, we scroll to the intersection point that we would like to find using the right arrow key. Once we get close to that intersection point, we press Enter 3 times. The first time selects the first curve, the second time selects the second curve, and the third time gives us our point of intersection. We see that the point of intersection occurs when the x value, or the t value, is approximately 21.18034. So the values of t for which the mathematical model makes sense are from 0 to 21.18034.